In this video, we are going to cover the last collection of the Java collection framework. It's not that there are no more collections to learn or to cover, but the thing is, if we talk about the core Java collection framework, then we have maps, sets, lists, and queues. There are other collections, but they are specific to the concurrency. There are concurrent collections. But we are not going to cover the concurrent collections. They will be covered in a separate series when we learn about the concurrency and the multi-threading. So we will be wrapping up the collection series with the queue. Let's start with the queue. Queue is a data structure which supports the FIFO order, which means first in and first out. There are two logical ends, back and front. We add a new element at the back and call this operation enqueue. And we remove the element from the front and we call this operation deque. So the element that was added first will be removed first. Now the queue data structure behaves in the same way, same as any other queue or any other line that we may have at the bank or at the hospital. So the person who enters first will leave the line first. That is the FIFO order. Alright. So in Java, we use the queue interface to represent a queue. Here, if we open the queue documentation, then this is the interface that represents a queue, and it has methods like add and offer, remove, poll, element, and peek. What it means, there are two flavors of these methods. One category throws the exception and the second category does not throw the exception, but it returns a special value. So to insert an item, we can either use add or offer. The difference is add can throw an exception. So let's say we are trying to add an element, but for some reason the element or the queue cannot add the element. In that case, the operation will throw an exception. But if we are adding the offer method to add an element, then instead of throwing the exception, it will return a boolean, true or false, that will represent if the value or the element was added to the queue or not. Similarly, to remove the method from the queue, we can use the remove. It will again throw the same exception if for some reason it cannot remove the element from the queue. We can also remove the element using the poll method, which will not throw the exception. It will return the item if it was able to remove the item from the queue. If not, then it will return a null value. Similarly, if we don't want to remove the item, but we simply want to check the item, we can do that with the help of element method. If we call the element method, then it will not remove the item from the queue, but it will simply return the item that will be removed if we call the remove method. And it will throw an exception same as add or remove. Similarly, we can use the peek method that will not remove the element, but it will simply return the item that will be removed if we call the poll method, but it will not throw the exception. So that is the difference between two categories, add, remove, and element, and offer, poll, and peek. There are three categories: insert, remove, and examine. So that is the queue interface. Okay, moving on. Next thing that we are going to see is the Deque interface. Deque is another interface that extends the queue interface. That means a Deque can be used as a queue and it can also be used as a doubly ended queue. A doubly ended queue is a queue in which we can insert and remove methods at both the ends. Okay, so if we open the documentation, then we have three major categories: to insert an element, to remove the element, and to examine the element. The first category of methods throws the exception, no such element exception. The second category of these methods does not throw the exception, but they return a special value, boolean or null. Because Deque supports insertion and removal of elements at both the ends, so we have two versions of each method. For example, add first, offer first to add the element at front. Then we have add last and offer last to add the element at back, which is called the tail of the Deque. Similarly, to remove the first element, we can use either remove first or poll first, and to remove the element from the back, we can use remove last and poll last. And similarly, we have peek first, peek last, get first, and get last. All right. We said that the Deque interface extends the queue interface, so we can use a Deque in place of a queue. To do that, in the documentation, we can see the equivalent methods of queue and Deque. For example, to add an element in the queue interface, we have the method add. But with the help of Deque, we can get the same behavior with the help of add last method. So that means we add the method at back, but we remove the method from the front. And that's why we see add last and offer last to add the element at back, but remove first, poll first, get first, and peek first, which is basically to get the element from the front to achieve the queue behavior. Deques can also be used as a stack. In stack, we have push, pop, and peek. Push to push the element to add the element, pop to pop the element to remove the element from the stack, and peek is simply to check the element without removing the element from the stack. The equivalent methods in the Deque interface that we can use in order to achieve the stack behavior is add first, remove first, and get first. So we do everything at front. All right. Let's see a quick demo to understand how do we use all these interfaces. Okay. There are two general purpose queue implementations that we can use, array Deque and priority queue. Priority queue we will see in the next video. In this video, we are going to simply use array Deque. Now we can use the queue interface here instead of Deque, but in order to have the maximum flexibility, we are going to use Deque interface because Deque supports not only the queue operations, but doubly ended queue and stack operations as well. All right. But before doing that, let's cover the stacks as well. Stack is another operation which supports the LIFO order, which means last in and first out. So that means, let's say we push an element 1, then we push the element 2, it goes to the top. Then we push the element 3, it goes to the top. And in the same way, we push multiple values 4, 5, and 6. So at this stage, we have the stack where we have the order 1, 2, 3, 4, 5, and the newly added element 6 is at the top. Then if we remove the element from the stack, and we call the remove operation pop. So if we pop an element, the newly added element will be removed as part of the pop operation. So if we pop this stack, then we get the element 6. If we pop again, then 5, then 4, then 3, then 2. So it is basically last in, first out. 6 was the last element added to the stack, so it will be the first element popped out from the stack. Okay. Now let's see how to implement a stack using array Deque, which is a Deque. To do that, we simply say offer first. And let's add element 1, then 2, and then 3. So we are simply adding elements at front using offer first. Okay. To check the element without removing it, we use the method peek first. And if we run this code, we see the value 3 on the console because currently 3 is at the top of stack. Okay. Now in order to remove the method, we generally call pop, but because we are using Deque, we can call, let's say, poll first. So we can say q dot poll first. So we see value 3 was removed when we called the poll first. Because 3 was at top of the stack, so when we called poll first, that item was removed from the Deque, and that's how we achieved this stack behavior, last in and first out. If we call poll first multiple times, then we would see the order 3, 2, and 1. Here 3, 2, and 1, which is last in and first out, because if we see, first we added 1, then 2, then 3, but when we removed the elements, we got the elements in reverse order, first 3, then 2, then 1. which is the behavior of stack, last in first out. So that's how we can implement a stack using an array deque. What about the queue operations? How do we implement a queue using a deque? So we know that in deque we can add and remove elements at both ends, and queue follows the FIFO order, first in first out. So what we can do, if you remember the documentation where it documents the equivalent methods, so in order to achieve the queue behavior, what we can do, we can always add a new element at back using offer last. All right. So we can always add a new element using offer last at the back, but when we remove the element, we will do that from the front. So the first item that will be added will be the first item that will be removed using using poll first. Let's see that. So we will always add the items at back using offer last. 4, 5, and 6. We added 3 items, and now we are going to remove all these items one by one in FIFO order, first in first out. To remove that, we will use the first. So we will remove the elements from the front. Okay. Before that, let me add the separator. So we see 4, 5, and 6. This is the same order in which elements were added to the queue. Here 4, 5, 6. And this is the same order in which we got the elements when we removed the elements from the queue. So that is how we achieve the queue behavior. Then we have next is implementing the deque operations, which is the simplest because we have all the variants first and last. So we can use poll first, poll last, offer first, offer last, whatever we want. Front and back both are available for insertions and removals. All right. And that covers our discussion on the queue and deque and how do we implement stacks and queues using deque. In the next video, we will cover priority queue.